Let's look at an application problem involving the law of cosines. A surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. While standing at point C, she finds that AC, that's this distance here, is 259 meters, BC is 423 meters, and angle ACB, is 132 degrees 40 minutes. I want to find the distance AB. Well, what I'm going to do is redraw this triangle, labeling the pertinent information. And here I have that. I have angle A, angle C, angle B. Angle ACB is 132 degrees 40 minutes. There's side AC and side CB. I'm interested in finding side AB. According to the law of cosines, side AB squared is side AC squared plus side CB squared minus twice side AC, side CB, times the cosine of the angle between them. The cosine of the angle between them, I'm just going to go ahead and write in, is 132 degrees 40 minutes. And then I'll fill in these values. Side AB squared is 259 squared plus 423 squared minus 2 times 259 times 423 times the cosine of 132 degrees 40 minutes. I'll want to crunch a number here, and if I do so, make sure your calculator's in degree mode. Side AB squared is 394,510.6. To get side AB, I'll take the square root of each side. I don't need to worry about it being negative since it's a distance. The square root of this number is about 628, which means the distance from A to B is 628 meters. Let's solve a triangle. We want to solve triangle ABC if angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. I'm going to start by using the law of cosines to find side A. According to the law of cosines, A squared is B squared plus C squared minus 2BC cosine angle A. I'll fill in what I know. A squared is 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. I'll grab my calculator and crunch a number here. A squared then comes out to about 109.7. Take the square root of each side, and I find side A to be approximately 10.47 meters, matching units. So I've got side A, side B, side C, and angle A. I need to find another angle. Using the law of sines, let's look for angle B. Using the reciprocal of the law of sines, I know that sine angle A over side A is sine angle B over side B. Recall that I'm looking for angle B. I know angle A, and if you look back at the given information, you'll see that it's 42.3 degrees. I just found side A to be 10.47. I'm interested in solving for angle B. Side B I was given as 12.9. Multiplying by 12.9, isolating sine B, I end up with 12.9 sine 42.3 degrees divided by 10.47. And if I stop and calculate angle B at this point by finding the inverse sine of this, angle B is approximately 56.0 degrees. So I have angle B, I have angle A. I know sides A, B, and C. All I'm missing in solving my triangle is angle C. To find angle C, I'll take 180 degrees, subtract angle A, which is 42.3 degrees, and subtract angle B, which is 56 degrees. Angle C then comes out to 81.7 degrees, and I've solved my triangle. Let's solve a triangle. We want to solve triangle ABC. If side A is 9.47 feet, side B is 15.9 feet, and side C is 21.1 feet. Well, if we're given three sides, we cannot use the law of sines, so we're going to have to use the law of cosines. Let's start this one by solving for angle C. Angle C is found using this version of the law of cosines. C squared equals A squared plus B squared minus 2AB cosine angle C. What I can do is put in the values for A, B, and C and isolate cosine C. Let's actually isolate cosine C first by subtracting A squared as well as B squared, and then divide by negative 2AB to get cosine C is C squared minus A squared minus B squared divided by negative 2AB. I can use this in this form, or I could pull the negative to the numerator, which will make the C squared negative and the A squared and B squared positive, which would look like A squared plus B squared minus C squared over 2AB. So let's continue on another sheet. What we found is that the cosine of C is A squared plus B squared minus C squared over 2AB. And I want to fill in these values. Filling them in, for A, I'll use 9.47. For B, 15.9. For C, 21.1. So again, for A, 9.47. For B, 15.9. Now with the help of the calculator, crunch this number, and you'll see that it comes out to about negative 0.34109, etc. Solving for angle C with the help of a calculator by finding the inverse cosine of that number, angle C is about 109.9 degrees. Now, I need to find the other two angles. Let's use the law of sines to find angle B first of all. So according to the law of sines, I can take sine of C divided it by side C, and that's equal to sine of angle B. Actually, sine of angle C divided by side C equals sine of angle B divided by side B. Angle C I just found to be 109.9 degrees. If you look back at the original information, side C is 21.1. We're looking right now for angle B. That's the thing we don't know. Side B is 15.9. Isolate sine angle B by multiplying by 15.9, and we'll calculate 15.9 sine 109.9 divided by 21.1. Finding the inverse sine of all of this, you'll get that angle B comes out to about 45.1 degrees. I've got angle C, here it is right here. I've got angle B. I know all three sides. All that's left is to find angle A. We'll find it by taking 180 degrees, subtracting 45.1 degrees, and subtracting 109.9 degrees. Making that calculation, A comes out to 25.0 degrees, and we solved the triangle. Let's look at an application problem. We want to find angle B for the truss shown, and what we see is side C is 9 feet, side B is 6 feet, side A is 11 feet. We want to find angle B. Using the law of cosines, we're going to use the version that B squared equals A squared plus C squared minus 2AC cosine angle B, because we're looking for angle B. We'll start by subtracting A squared as well as C squared from each side, and then dividing by negative 2AC, which will give me cosine angle B is B squared minus A squared minus C squared divided by negative 2AC. I'll move the negative to the numerator, distributing it to get cosine angle B is a squared plus c squared minus b squared all over 2ac. And now I'm ready to put in the lengths of the sides. If you look back, the lengths of the sides, a is 11, c is 9, b is 6, and so I divide by 2 times 11 times 9. If I find the inverse cosine of this with the help of a calculator, well, actually, maybe we'll calculate this value first and say that the cosine of angle B is the decimal 0.8383, etc. Angle B, then, finding the inverse cosine of this value using a calculator, comes out to about 33 degrees. Let's work an application problem. The distance as the crow flies from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles. And from Montreal to Los Angeles is 2,427 miles. What is the area of the triangular region having these three cities as vertices, ignoring the curvature of the Earth? Well, a good thing to do with a problem like this is to draw a picture. I'm going to draw a triangle, labeling the vertices with the three cities, and labeling the sides with the distances between them. So here we go, and this is not to scale, but I've got Los Angeles, I've got New York, I've got Montreal. I want to put in some sides. The distance from Los Angeles to New York was 2,451 miles. The distance from New York to Montreal was, or is, 331 miles. The distance from Los Angeles to Montreal, 2,427 miles. I want to go ahead and letter or give some letters to the sides so I can fit them into the formula for finding the area. I'm going to call this side A, this side B, and this side C. We want to find the area of this triangle. We're going to use Heron's formula. According to Heron's formula, first I need to find S. S is 1/2 of the perimeter, A plus B plus C. In this case, that's 1/2 of 2,451 plus 331 plus 2,427. With the help of a calculator, S comes out to 2,604.5. So now, to get the area, I find the square root of S minus A. Well, actually, I start with S, 2,604.5, times S minus A times S minus B, and I have to have that in the radical times S minus C. That's a minus 2,427. So this times carries over to this. Well, we need to crunch a number on our calculator. If you crunch this number on your calculator, you'll see that the area comes out to 401,700 square miles.